Okay, let's take a look at the second day of 10.1. Yesterday we did some vocabulary and some basic ideas. Today we are going to look at how I can show that a line is tangent to a circle. Meaning, how can I show if I have a circle, I have this line sitting out here, how do I actually know if that's tangent to the circle or not? So that's what we're going to be looking at today. So just some vocabulary stuff and things to remember. What is the vocabulary word that means two lines meet at a right angle? Well, that vocabulary word is perpendicular, and we're going to use that idea today. Okay, and if they are perpendicular, remember, we would have that little square in the corner. How can I tell if a line is tangent to the circle? Well, a line is tangent to the circle if it is perpendicular to the radius. So if it is perpendicular, get the pen here, to the radius. So what that means, as we come back up here and look at my picture here, if I have a radius and these two make a right angle, then that means that, yes, that line is tangent and that other segment is a radius, okay? And we're going to be using the Pythagorean theorem. We've used the Pythagorean theorem. Remember, it's a squared plus b squared equals c squared. Okay, so let's look at an example. So here we have a circle, and this segment right here is on the outside. What we're wanting to know, is that tangent to the circle? That's what we're trying to figure out. And in order to do that, we are going to use our Pythagorean theorem, a squared plus b squared equals c squared. So let's define what's a, what's b, and what's c. Well, our radius is going to be a. So if you notice, these two, the tangent and the radius, are the two that intersect, and we're trying to decide if that makes a right angle. So the radius is going to be a. So in this case, our radius is 3. Our tangent is going to be b. Those are our legs, right? So these two are the legs. So b is going to be our tangent segment here, which is 4. And then our hypotenuse is always the longest side. Just a reminder of that. And in this case, our hypotenuse is this guy right here, which is going to be 5. So then we just have to ask ourselves, does a squared plus b squared equals c squared? So we've got a little question mark there. So we'd have a is 3, so we'd have 3 squared. B is 4, so we'd have 4 squared. C is 5, so we'd have 5 squared. So if we calculate that out, 3 squared plus 4 squared, 9 plus 16 is 25, and 5 squared is 25. So if these are equal, then the answer is yes. It makes a right triangle, makes a right angle. Kind of learned that last chapter with the chapter 9 with trig, where we said, is it an acute, obtuse, or right triangle? Well, if it was equal, that meant it was a right triangle, and that's what we're looking at here. Okay, so let's take a look at another one here. All right, we've got, here's our tangent segment. All right, so here's our tangent segment. A tangent, remember from yesterday with our vocabulary, is on the outside. B would be the point of tangency. So that's going to be our tangent. That's going to be B. This guy here is our radius. Okay, that goes from the center to the outside, so that's going to be A. And then this guy here, we're asking if that makes a right angle, so this is going to be our hypotenuse, or C. So our A value is 9, our B value is 15, and our C value is 18. And if we calculate that out, we're asking ourselves, does 9 squared plus 15 squared equal 18 squared? We're asking that question. Well, 81 plus 225 is 306, and 18 squared is 324. That does not equal each other, so that means that no, this is not actually tangent to the circle. So this line up here, this little tangent line on the outside, does not actually, must either be a little above it, might actually go through the circle a little bit, but it's not exactly tangent where it meets at one point. Okay, let's look at one more that can be a little bit more tricky. Okay, so remember our radius is A, so here's our radius from here to here. So our radius is 12. Okay. B is our tangent. That's this guy here. He's 16. Okay. And C is our hypotenuse, which goes all the way from point B to point C. 8 only represents this little section on the outside of the circle. And if you remember from our vocabulary, the length of all the radii in a circle is the same, which means the hypotenuse is not 8. The hypotenuse, if this radius is 12, this radius is 12 also. So our hypotenuse is going to be 8 plus 12, which is 20. Okay, so then let's do a check here. Does a squared plus b squared equals c squared? And 12 squared plus 16 squared equals 400. 20 squared is 400, so then we're going to be, yes, it is tangent. Okay? All right, so now that's just with numbers. Of course, we're going to add a little bit of algebra into our geometry world. Do you remember, this is one of the skills we're going to use today when we're using the algebra to figure out if a segment is tangent. The box method, that's how some of you, depending on who your teacher was, that's how I teach multiplying binomials. X plus 3 is a binomial. Bi means 2. X is a term. 3 is a term. That's 2 terms. Okay, so if we have x plus 3 squared, that does not make x squared plus 9. That is a big no, 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 no. Okay, just make sure you remember that. It is not, you don't just distribute that squared to both. That is not how algebra works. Okay, so we are going to say we are not going to do that. And we are going to remember that if we have x plus 3 squared, that means we have x plus 3 times x plus 3. And what we do is we multiply. We would have to go in this first box here. Okay, we would have x times x, which would be x squared. And then to go in this box over here, we'd have 3 times x, which would be 3x. And then to go down in the lower left, we would have x times 3 again, which would be 3x. And then we'd have 3 times 3, which is 9. And then what's in the box on the opposite corners here is going to be some like terms that we can put together. So we would have x squared plus 6x plus 9. Okay, so let's look at one more here, x plus 5 squared. So we're going to put x plus 5 here, and we're going to put x plus 5 here. X times x is x squared. X times 5 is 5x. X times 5 is another 5x. And 5 times 5 is 25. Again, you're going to have these two guys on the corners, the x's that are like terms, so you would have x squared plus 10x plus 25. Okay, so we are going to use that idea where you have to use the box method to multiply some stuff out to solve with a little bit more complicated problem. Okay, it's going to put it all together. We're going to find the radius. In this case, we don't know what the radius is, and we're going to use a little bit of algebra and that idea with the Pythagorean theorem to figure out what the radius is. Well, the radius in this case goes from here to here. Well, our radius is r. Okay, our tangent, that's the guy here on the outside. Tangent's going to be 24. Okay, and our hypotenuse goes all the way from here to here, which means it's not 16 and it's not r. It's those two things together, which is r plus 16. That's just segment addition. Okay, we're adding two segments together to get r plus 16. Okay, so let's use our Pythagorean theorem. Well, a in this case is r, so we would have r squared. B is 24, so we would have 24 squared. C is r plus 16 squared. Okay, so what we're going to do, first thing we need to figure out is what's r plus 16 squared. So we're going to come over here to the box that I've provided. We're going to have r plus 16, and we're going to have r plus 16. Okay, let's box this baby out. We got r times r is r squared. r times 16 is 16r. r times 16 is 16r. 16 times 16 is 256. Okay, so on the left-hand side of our equation here, we have r squared plus 24 squared. Okay, so that's going to be r squared is just r squared. Okay, 24 squared is 576. And then we're going to have our result here. We have equals r squared plus 16 and 16 is 32r plus 256. Okay, so we need to get r all by itself. Well, nicely, in the problems we're doing, we have r squared on the left and we have r squared on the right. If we want them to be on the same side, I'm going to subtract r squared from both sides. What that does, whoosh, whoosh, no more r squared. So now we have 576 equals 32r plus 256. Okay, so 576 equals 32r plus 256. When we subtract 576 minus 256, we get 320. If we divide both sides by 32, we get that our radius equals 10. Okay, so we had to do a little bit of all the things that we've talked about in this lesson so far. Identifying the parts of our triangle with the circle, doing a little bit of the box method, Pythagorean theorem, putting it all together. Okay, so let's look at one more example here. Okay, here's our diagram. Our radius, again, our radius doesn't have a value, it's just r. Our tangent value is 9, that's the one on the outside. And our hypotenuse is going to be r plus 6 because we have segment addition. Okay, so we got a squared plus b squared equals c squared. So I'm going to have r squared plus 9 squared, that's our a squared plus b squared from up here, equals r plus 6 squared. Okay, so let's hop over here. We got r plus 6, and we've got r plus 6. Multiply that out real quick. R times r is r squared. R times 6 is 6r. R times 6 is 6r. And 6 times 6 is 36. Putting these two like terms together. Oops, hang on a second. I made a little mistake here. Did we catch that? It should be r squared plus 9 squared. There should not be an r squared right there. There should be, it just should be 9 squared. I apologize, that was my bad. Some of you were probably being like, Mrs. Kreifel, stop typing, stop writing. Okay, so we have r squared plus 9 squared. That's all we needed there. So we have r squared is just r squared. 9 squared is 81. We multiplied this out over here, which is going to be r squared. 6r and 6r is 12r plus 36. And on all these that we do now, the r squareds are going to cancel. So if I subtract r squared from both sides, I just get that 81 equals 12r plus 36. Okay, and we're going to end up at, if we subtract 36 from both sides, we have 45 equals 12r. If we divide by 12, we get that our radius is 3.75, which is fine for our radius to be a decimal value. That's not a big deal. It's a distance, it's a length, so it can be whole numbers, fraction, decimal, anything that we want, and it works out just fine. So the fact that it's, don't freak out if your answer ends up being a decimal like that. We would just use 3.75 as our answer. When you go to do your class kick today, there's going to be places where you have to show your substitution. Okay, so just make sure you're showing your substitution here and showing all your work on there. I believe on the class kick, oops-a-daisies. Let's see here. It's going to want just your substitution here. Okay, so it's going to want, let's highlight so you can kind of see. It's going to want this substitution right here. Okay, you don't have to type. You should have this work shown. You don't have to type that line in. You just have to type in this gray highlighted line. So if you're kind of confused on what to put in into the class kick, you would actually be putting in this row here that's highlighted. So that's the row that you're going to put in, and then you will also have to put in your answer for your class kick, okay? Which means that your homework for today is the other half, so you're going to finish your class kick from yesterday for homework. Good luck.